Hello students, welcome back to the Trockers. So this section presents the ZIMSEC November 2026 released specimen questions aligned with the new syllabus 6082. But even those taking the 6042 syllabus could still attempt these questions. They were just designed to help us understand the structure of the examination, content, as well as help us to improve our readiness for the exam. All right, so we have a vector, a question on vectors. It reads, the position vectors of the villages A, B, and C are negative 2i plus 3j minus 6k, negative 2i minus j minus 3k, and negative I plus 3j minus 7k, respectively. A, find the distance between village A and village B. B, during a survey, the engineer surveyed a straight line from village A to village C. Find the vector equation of the line in parametric form. C, the engineer surveyed another straight line from village B to village C. A borehole is to be drilled somewhere in between the surveyed lines. Calculate the maximum angle that makes the position of the borehole lies anywhere between the surveyed lines. D, the three villages are represented in the Cartesian plane. Find the equation of the plane containing the three villages. All right, so before we attempt these problems, guys, let's just do the annotations. So the first one here, we want to find the distance between villages A and village A and village B. Remember, we are in vectors. So in other words, they are just asking you to, they're just asking you to find the modulus of vector AB, because that's the distance between A and B. Then we are told that during a survey, the engineer surveyed a straight line from village A to village C. Find the vector equation of the line in parametric form. So what we are looking for here, it is just the vector equation of a line. And we know that for a vector equation of a line, it will be in the form R equal to OA plus lambda, then D, which is our direction vector. But we are supposed to express this in parametric form. So it means X will be equal to something, Y will be equal to something, and Z will be equal to something. But they are all expressed in terms of what? In terms of the parameter. In this case, it's lambda, right? Then on part C, the engineer surveyed another straight line from village B to village C. A bore is to be drilled somewhere in between the surveyed lines. Calculate the maximum angle. So here we need to find the maximum angle that makes the position of the bore lies anywhere between the surveyed lines. But remember, at first they surveyed from A to C, right? And now they surveyed from what? They surveyed from B to C, right? So from B to C. So it means we have sort of like okay, we have this angle here. That's the maximum possible angle, because what happens is if the bore is to be drilled here, it means the angle is obviously reduced depending on the position, but the maximum angle is this part here, right? So we cannot go beyond those endpoints, which is AC and AB. So in other words, they are just asking us to find the cosine angle here. So here we're going to find the cosine AC, and we know the formula, right? Which is AC dot, CA dot CB, right, over the modulus CA and CB, right? Then lastly, in other words, we are trying to find a plane that contains three non-collinear points, right? So, and we know how to find the equation of a plane. We need the normal and any other point. But in this case, we have a common point, which is C, since we have vector AC already and vector BC. So we'll make C or A, depending on the question. Let's see when we get there, but we just need a common point. If we are to make A the common point, then we find vector AB and vector AC. Then from there, we need to calculate the normal, and we know that finding the normal here, we have to find the cross product between those two. Then once we do that, we should be good to go. So guys, without further ado, let's go ahead and get started. Okay. All right. So the question reads, right. The position vectors of the villages A, B, and C are that. So let me write those position vectors in coordinate form. All right. Number 12. Sorry. All right. So this is number 12. So I have -2. So that's A. So for A, I have -2, 3, and -6. Then for B, I have -2, 3, and -6. I have -2, -1, and -3. Then for C, I have -1, 3, and -7. Okay, so now that I have these points, part A, so on part A, we need to find we are looking for the distance between village A and village B. So let's find vector AB, hence its modulus. So vector AB is equal to head, our B, right, minus tail, right? So here it was that B minus C. So our B here is what? Let me just say B minus C. So it's -2, -1, -3, subtracting -1, 3, -7, which is equal to -1, and we have -1, right? Wait, it's A and B, I'm sorry. I don't know why I wrote C there. All right. Okay, so it's going to be B minus A. All right, okay, so our B, it's -2, -1, -3, subtracting -2, 3, -6. Here it's 0, -4, 3, right? 0, -4, and 3. So this implies that the modulus of AB is just equal to square root of 0 squared plus -4 squared plus 3 squared, which is equal to square root of 16 plus 9, which is equal to square root of 25. So here the distance is 5. Right, the distance is 5. So we are done with part A. Okay, let's move on to part B. So on part B, during a survey, the engineer surveyed a straight line from village A to village C. So it means if it's a straight line village A to village C, we need to find, this is B, so we need to find vector AC, so which is just C minus A, right? And our C in this case, our C was -1, 3, -7, subtracting our A is -2, 3, and -6. So here it's -1 plus that is 1, 3 minus 3, that's 0, -6 plus this, that's negative what? That's -1. So this is our direction vector. So therefore, right, the equation are equal to, so A here was -2, 3, -6 plus lambda, then 1, 0, -1. So guys, you could still use C, or even A, it's okay, because we must have a specific point on the line plus the direction vector. All right, now that's all for part B. Let's move on to part C. So on part C, we are told that the engineer surveyed another straight line from village B to village C. A bore is to be drilled somewhere in between the surveyed lines, right? So remember, we have our vector AC, right? We got it. I think we calculated vector. I have vector AC. I also have vector AB. It's okay. All right. So here, or let's quickly say C minus A, right? So our C here is -1, 3, -7. Then our A is -2, 3, -6. which is 1, 0, negative 1. Then we also need, because on item B, on item C, it was now from B to C, right? So it's from B to C, meaning say we need C minus B. So our C here, it's negative 1, 3 minus 7, subtracting B. Our B is negative 2, negative 1, negative 3. So here that's 1, 4. Negative 7 plus 3, that's negative 4. Right. So once we get the two vectors, let's go ahead and find their respective moduli. So here it's just square root of 1 plus 1, which is square root of 2. And here is just square root of 16 plus 16 plus 1, which is square root of 30, square root of 33. So now we are finding the vector, now we are finding the angle, right? Which is, remember, they surveyed, we need a diagram here. On item B, it was from A to C, right? So they surveyed this from A to C, right? And for item C, they surveyed from B to C again. So we have our common point, which is C. So we are looking for this maximum angle here, right? So hence, what we are looking for is here is angle. So we say cosine ACB, right, which is equal to CA dot CB over the modulus of CA by the modulus of CB. So our CA over root of 2, root of 33. So our CA here, it was 1, 0, negative 1. So we have 1, 0, negative 1. Then our CB is 1, 4, negative 4. So we have 1, 4, negative 4, right? This simplifies to 1 plus 4 is 5 over square root of 2, square root of that. So cos ACB. So therefore, ACB equal to arc cos of 5 over square root of 2, square root of 33. So let's go ahead and calculate this. So it's a shift cos 5 divided by square root of 22, square root of 2, sorry. That's square root of 2 times square root of 33, right? And make sure we are in degrees. I was in radians here. All right, so it's 52. So that's 52.014832.7. So therefore, in this case, the maximum angle is 52 degrees to the nearest degree. Remember, for ZIMSEC, we approximate angles to the nearest angle, and for Cambridge is to 1 decimal place. So let's bear that in mind. All right, so now we are moving on to the last part. So last part now, this is what I was talking about earlier on. This is item D. So we have our plane here, something of that sort, right? Then we have 3 non-collinear points, right? So our points, we have B, we have A, and we have C. So we are going to calculate vector AB and we're going to calculate vector AC. Then from there we have our arbitrary point P, right, which is generic coordinates X, Y, and Z, right? So here, once we find these two vectors here, we now need to find the normal. Remember, the normal is just perpendicular to each vector, to each vector or to each line in the plane, right? So once we get to that part, we get our vector AB and vector AB and AC, and we know that we are going to get our normal by taking the cross product of AB and AC. Then when we have our normal, we know that if we say if we take this point P, which is this point PA, so if you calculate point AP or PA, right? Let me calculate AP so that we don't have negatives for that. So if we calculate this AP multiplied by the normal, we should get 0. If we take that dot product, because they are perpendicular. So that's how we get the equation. There are several methods which you could use, but I prefer this one. So let's go ahead and calculate vector AB. So our vector AB is B minus C. We calculated that vector above, but let's just do it, right? So AB, it's B minus C, so it's -2, -1, -3, subtracting, I don't know why I'm always saying that, it's B minus A, so subtracting -2, 3, and -6. So I'm getting -2 minus that, that's 0, -4, 3, right? Then we also need AB. We also need vector AC, right? So AC is equal to C minus A, right? So when you get C minus A, which is equal to -2, so C is -1, right? -1, 3, -7, subtracting -2, 3, -6, and here we get -1 plus 2, that's 1, 3 minus 3, that's 0, -1, right? So we have this vector. So now let's go ahead and find our normal vector, which is ijk. So the first one is 0, -4, 3, and this one is 1, 0, -1. So if we take the determinant there, which is we're calculating the cross product, here it's going to be I, right? So if you have delete this and that, you have -4, 3, 0, -1, minus j, right? You have 0, 1, 3, -1. Okay, so it's 0, 0, 1, 3, -1 plus k, right? 0, -4, 1, 0, right? So here it's 4 minus 0, so that's 4i. Then negative, that's 0 minus 3 plus that is plus 3j. Then 0 minus minus 4 plus 4k, right? So our normal vector then, it's 4, 3, 4. So you could write it like this, or in column form is 4, 3, 4. So now that we have our common point there is A, and we have that one, so let's go ahead and find, so now if we say vector AP dot normal should get 0. So this implies that AP is OP. Remember, this is generic, right? XYZ minus A, the specific point here, we have used -2, 3, -6, right? Then times, right? So this whole thing times our normal 4, 3, 4, we should get 0 there. Okay, we should get 0. So it's going to be x minus minus 3. So it's now 4 times x plus 3, then plus 3 times y minus 3, then plus 4 times z minus 6, right, equal to 0. So 4x plus 12 plus 3y minus 9, then plus 4z minus 24 equal to 0. So 4x plus 3y plus 4z equal to 12 minus this negative 12, which is 21, if not mistaken. Is it 21, 23? Okay, this is 12, 19. Okay, let's see. This is 24, 9, 12. So 12 minus 24, that's, if I did the correct thing there, z plus 6. Yes, I have z plus, oh, it's supposed to be plus here, sorry. It's supposed to be plus, so here it's 24. So 24 plus that, 36. So what is 36 minus 9? 36 minus 9, I have, I'm getting 27, right? That's what I'm getting here. Let's see. Because it's supposed to be x plus 2. Okay, what is my point A here? Let me go back to A, I'm sorry. Our A from, okay, from where we studied here, A is negative 2, 3, and negative 6. Negative 2, 3, and negative 6, all right. No problem. So it's supposed to be negative 2, 3, and negative 6. So here it becomes, right, it becomes x minus 2. So it's now x plus 2. And this is now 8, right? So it's now 32 minus 9. 32 minus 9, which is 23. So plus 23 equal to 0. So this plane here contains all 3 points. And if you want, guys, you can plug in those points one at a time. They should satisfy that equation. I think we need to go back to B. I forgot to do something on item B. All right, so on B, remember the question requires us to express it in, what do you call this? In parametric form. Yes, it said on B, yes, in parametric form. So this one here, that's the vector form, right? So the actual answers in parametric form are x equal to negative 2 plus lambda, y equal to 3, then z equal to negative 6 minus lambda. Now we have expressed that in parametric form, right? So guys, I think that's all. That's the complete solution for this problem. Make sure you understand each step before you proceed to the next questions. I will see you in my next video. Take care.